Today, we are going to talk about the factors of performance. So, the factors of performance is how quickly the computer can execute the programs. So, we always know the speed is affected by the design of the hardware. So, time is also the main factor to measure the performance. So, here we are going to learn the terms execution time, throughput, and CPU execution time or CPU time. The execution time is otherwise called as a response time, the time between the start and completion of the program. The throughput is the amount of work done per unit time. And the CPU execution time is time that spent CPU for computing for a particular task, including the time spent for input output wait or other running programs. And here the CPU time is classified into two. The first one is user CPU time and second one is system CPU time. The user CPU time is CPU time spent in the program and the system CPU time is CPU time spent in the operating system on behalf of the program. So differentiating these two times are very hard if any process is running inside the system. So the next two important terminologies are processor clock. And processor circuits are controlled by the timing signals called clock. And clock is regular time intervals called clock cycles. And CPI or IPC. CPI is the clock cycles per instruction and IPI is the instruction per cycle. And speed up ratio. The speed up is equals to ratio of execution time before by ratio of execution time after. Clock cycle. The clock cycle we always called as in the time interval between the two racing edges of repetitive clock cycle. And speed of a clock. A clock speed or clock rate or clock frequency is not a metric for the performance of a processor. The clock rate only tells how often the clock signals inside the processor chips goes up and down. So, for example, the modern Apple M1 processor running at 2.5 gigahertz clock speed in many times, as it is faster than the old Pentium 4 processor, which is run at 3.8 gigahertz clock speed. Then, how clock speed is measured? So, clock cycle is measured in hertz, which represents the number of cycles per second. So, today the important topic is all about the factors of performance. So the first we are going to see what's the execution time. The execution time is also referred as the response time. So reduction in response time increases the throughput. As we already said, throughput is the thing which is calculated by the amount of the executed per unit time. So here we want to calculate the performance of a computer. For example, if you want to performance a particular thing, the performance is equals to inverse of the execution time. So this means if we want to calculate the performance of two computer as performance of A, if it is performance of A is greater than performance of B, performance of A is calculated by 1 by execution time of A. So obviously the execution time of B is greater than execution time A. So if you want to calculate the performance of two computers, we have to calculate by performance time of A by performance time of B equal to N. So obviously we will get performance of A by B equal to execution of B by A equal to N. If you see the first problem, for example, we want to compare the two computer and we have to find which computer is faster than which and how much. So we have to calculate performance of A by performance of B. We know the performance of A by performance of B is equals to execution time of B by execution time of A. So the execution time of B is 25 and the execution time of A is 10. So we are getting the performance 2.5. That means the A is 2.5 times faster than B. We could say that the computer B is 2 times slower than computer A. And second problem in factors of performance, here we have to calculate the CPU execution time of the program. We want to calculate the CPU execution time of the program. The formula is CPU clock cycles for a particular program into clock cycle time. This clock cycle time is also referred by 1 by clock rate. So CPU execution time of the program is rewritten as CPU clock cycle for a program divided by clock rate, because this clock time is equals to 1 by clock rate. So what is this clock rate? So the definition for clock rate is the number of clock cycles a processor can execute per second. It is usually measured in gigahertz. And clock cycle time. The amount of time taken to complete one cycle is called as a clock cycle time. Problem 2. A computer runs a program in 12 seconds with 3 gigahertz clock. And we have to design a computer B such that it can run the same program with 9 seconds. So already a program is running for 12 seconds in a computer A, and we want to design the same program has to run in 9 seconds. So they determine the clock rate for computer B and assume that due to increase in the clock rate, CPU design of the computer B is affected, and it requires 1.2 times as many clock cycles as computer A for executing the program. For example, here the computer program is running 12 seconds with 3 gigahertz, and we have to design a computer B. It has to run the same program in 9 seconds. But we have to take one thing, that is CPU design of computer B is affected and requires 1.2 times as many clock cycles as computer A. So let us solve the problem. We have the clock rate of A, 3 into 10 power 9 cycles per second. If it is a gigahertz means we have to take it as a 10 power 9. And CPU time of A is 12 seconds and CPU time of B is 9 seconds. So we have to calculate the CPU time. As we know the formula, CPU time is equals to CPU clock cycles of a specific computer divided by clock rate. Now CPU time of A is 12 seconds is equals to CPU clock cycles of A divided by clock rate. A's clock rate is 3 gigahertz, so 3 into 10 power 9 cycles. From this, we can calculate CPU clock cycle of A. So the CPU clock cycle of A is equals to 12 seconds into 3 into 10 power 9 cycles per second. So totally 3 into 10 power 9 cycles is the CPU clock cycle of A. So by using this information, we have to calculate the CPU clock cycle of B. So if you want to know the CPU clock cycle of B is, as we know, this is B is 1.2 times greater than A. So we have to rewrite the formula as CPU time of B is equals to CPU clock cycle of B divided by clock rate. That is CPU clock cycle is 1.2 times greater than of CPU clock cycle of A. So 1.2 into CPU clock cycle of A divided by clock rate of B. We know only the CPU clock cycle of A, we don't know about the clock cycle of B. So first we have to calculate the clock rate of B by using this above formula. So clock rate of B is equals to 1.2 into 36 into 10 power 9 cycles divided by 9 seconds. So totally we are getting 4.8 cycles per second. In problem 3, before we are before we see get inside the problem 3, we want to know the basic equation of computing the clock cycles T. T equal to N into CPI divided by clock rate. N is the number of instructions. T is the CPU time. We want to find the CPU time of a program. So the formula is N. N is the number of instructions and CPI is the clock cycles per instruction and divided by clock rate. As we know, 1 by clock rate is equals to clock cycle time. So we have to rewritten the formula as n into CPI into clock cycle time. So here CPI equal to CPU clock cycles divided by instruction count. As we know, CPI is the clock cycles per instruction. Clock cycles per instruction. So we can rewrite as CPU clock cycles divided by instruction count. And problem 3. Let us assume two computers use the same instruction set architecture and A has the clock cycle time of 250 per second and clock cycles per instruction of 2.0 for the same program. And computer B has the clock cycle of 500 per seconds and CPI of 1.2 for the same program. We have to find which computer is faster for this program and by how much. So the clock cycle of A is equals to n into 2.0 and clock cycle of B is equals to n into 1.2. So we know that each computer executes the same instructions. So we have to take that as n. So CPU time of each machine will be calculated by CPU time of A is equals to CPU clock cycles into cycles time. So here the cycle time of A is 250 and clock cycle is n into 2.0. So we got here is 500 n per second. N is the number of instructions. By the same way, we will get the CPU time of B. So we have to compare the performance. So 500 instructions per second is lesser when compared to 600 instructions. So we have to rewrite, we have to use the formula CPU performance of A by CPU performance of B. As we know, the CPU performance is equals to inverse of execution time. So we at last, if we are applying the formula, we will get 1.2. So we can conclude computer A is 1.2 times faster than computer B. And next problem 4 is there are two code sequence with number of different instruction as given. The instruction of classified as A, B, and C. There are three instructions are given in the table. That is instruction A, instruction B, and instruction C. And the code sequence of this instruction is 1 and 2. So by this given data, we have to find the which code sequence execute the most instruction and determine which code sequence will execute quickly and determine the CPI of each code sequence. Solution 1, we have to calculate the code sequence of instruction 1. The code sequence of instruction 1 is calculated as we know, the code sequence 4 plus 2 plus 4 is equals to 10 instruction and code sequence 2 executes with 8 plus 2 plus 2 is equals to 12 instruction. Therefore, code sequence 2 executes more instruction. The next question is we have to find the CPU clock cycle required to execute this sequences as given. First CPU clock cycle is given with 1 and for second is 2 and third is 3. So if we want to execute the clock cycles, we have to multiply that with instructions given. So for first one, we are getting the 20 cycles and second one, we are getting the 18 cycles. Now we have to say that the code sequence 2 is faster than 1. So we know that the CPI formula, CPI is equals to clock cycles divided by instruction count. So the 20 is the clock cycle and instruction is 10 and 2.0 is the CPI of the first computer and CPI 2 is equals to 18 divided by 12 that is 1.5 is the CPI instructions of the second computer. And problem 5, consider three different processes P1, P2 and P3 executing the same instruction set. P1 has 3 GHz clock rate and CPI is 1.5 and P2 has 2.5 GHz clock rate and CPU of 1.0, and P3 has 4 GHz clock rate and has CPU of 2.2. Which processor has the highest performance expressed in the instruction per second? If the processor executes a program in 10 seconds, find the number of cycles and the number of instructions in each processor. First question is we have to find the performance of three computers. So we have to find the performance of three computers. We know the clock cycle rate and CPI. So the formula, as we know, clock cycle rate divided by CPI rate. So for this first performance, we will get 2 into 10 power 9. First processor performance, and third processor performance we got 2.5, and third processor performance is 1.82. So we have to find number of clock cycles. As we know the formula, time into clock rate. So the cycles for the first processor is 30, and second is 25, and third one is 40. And we have to find the time. Time is equals to number of instructions into clock cycle per instruction divided by clock rate. So if we want to calculate the number of instructions, we already know the formula, that is 30 into 10 power 9 divided by 1.5, that is time into clock rate. Time into clock rate divided by CPI. So at last we get for all the processes instructions, the number of instructions of P1 is 20 into 10.9, P2 is 25, and P3 is 18.18. So thank you.